Please confirm if my screen is visible.
Visible, sir.
Okay then. So let's do a quick recap. So we were discussing about what is a data source. So this was the extra session, I guess. Okay. So data source is nothing but so when you it is a place where you get the data. Example, all the online applications. If you take any online application, they are going to generate a lot of data. So the end user inputs a lot of data. That data needs to be processed and stored in the database. So in this case, these online applications are the data sources. And what is a data storage again? It is a place where we actually store the data information. Okay, and we have discussed about the three data sources, three significant data sources in the real time. One is papers and books. So this is the typical data source or legacy data sources that anyone can affordable. You can store data in the form of paper or in any books. You can write down the data in the books. The second one is flat files or text files. So this is usually from the computers, right? And if you open any computer, the default file system is what? Text file is a default file system. And the last one you have what? You have the DBMS. So this is the evolution of storage devices. Evolution of storage devices. You have papers and books, you have flat files, and you have text file, and you have DBMS. And you can store data in the papers and books. And there are many disadvantages. Like you can see, there will be space consumption and updating the data manually. You find a lot of difficulties now. You want to update any data, and also it is not a legal entity and the limited backup. If you want to do any backup, again you need to do a lot of copies like Xerox copies and security issues. Anyone can see the uh, secret financial information. Security can be compromised. There will be a lot of time consumption and it is prone to damage and tear. So to overcome this problem, you got flat files from computer. So flat files, you can store the data digitally, but again, there are some limitations with the flat files. What are the limitations? If you see the limitations, you have limitations like what? Data redundancy, and you have data inconsistency, retrieval, integrity, security, and indexing. So redundancy means, just imagine, okay, just only one word has to come into your mind, which is duplication. Duplicate. When you see a duplicate, you can say that it is a redundancy. According to the database terminology, a redundancy is nothing but a duplicate data. Inconsistency. Okay, and again we have seen inconsistency means what? If one changes are happening and if the changes are not automatically synchronized, there will be some human errors. For example, if you're maintaining two databases, like one is a notebook and second one is a stack of receipts, okay, you have to update the two databases or two data storages simultaneously. If you miss one thing and if you tally the total, the total might be mismatching. So this is called as what? Inconsistency. Yesterday we have seen the joint account example. So that is what the data inconsistency is. And data retrieval, you talk about retrieval, the retrieval has to be very quick. If you are looking for a specific data, right, it has to be very quick. So in those days, if a software is required, or if a software is created to find the specific data, creating the software itself is going to consume a lot of number of lines of code. There will be more number of lines of code, and the application is very much complicated to design, to do the read operations, to retrieve the data, right? It has to be easy. So to overcome that, we have SQL. In SQL, with only one line, you can retrieve the data very easily, right? So we are just talking about disadvantages. And data indexing, we have in books, you have indexes, right? In flat files, there are no such things. You can maintain indexes, but it is again a complicated thing, right? And last, we have data security. So there is no security for the flat files. Anyone can come access and do some modifications without your knowledge, right? It will affect the if it will affect you financially, if you're dealing with highly secured financial data, right? And what are the last thing? That's it. So these are the data index. These are the drawbacks of flat files. To overcome these drawbacks, so we are going for database management system. As simple as that. So these technical words are very important to understand. We would be using these words very often. Okay. Now let us start today's class. Class number 5. Class 5. Class 5. Today's date is 6th January. Okay. So now we want to understand why we are going for database management system. So we have to understand what is DBMS. What is DBMS? What is DBMS? I can say that the DBMS has been introduced just to overcome the drawbacks. To overcome the drawbacks on the flat files, the DBMS has been introduced. Okay. So, right. Now focus here, guys. So now again, what is DBMS? DBMS is nothing but when someone is asking you, hey, what is DBMS? Can you tell me what is DBMS? You can say either it is an acronym for what? Database management system. Anyone can say this. Database management system. Then again you would get a question. Hey, can you please elaborate about this? Okay, very simple. DBMS is a software. That's it. DBMS is what? DBMS is a software which is used to what? Is used to manage and maintain the data in the database memory. DBMS is software which is used to manage or maintain data in the database memory. Okay. Having said this, it is not only used to manage and maintain data in the database memory. You can do lot of operation. DBMS is a very typical software which will enable you to perform a lot of operations. What are they? We will understand that one by one. Okay. Please be informed that DBMS software enables us to do a lot of following operations. Okay, the first major operation is you can create a memory. You can create a database memory. In that memory, you can store the permanent data. First and the most important thing, first of all, you can create what? You can creating database memories. So when you are creating a database memory, the data that you are going to store is going to be very much permanent. Okay, it is like if you want to create one database memory, you can create it just like that. Within a second, you can create a memory. It is a physical unit. So this memory is what? This memory unit is completely physical, and the data that you're storing is going to be very much permanent. Okay, you can create. If you want to create one database memory, you can create. If you want to create another database memory, you can create. If you want to create 4 database memory, you can create. Right? So it is very easy for you to create a database memory. In the real time, if you want to create any memory by using books, you need to purchase a new book. Okay, and again, if you want to create a memory by using flat files, you need to open a flat file and you need to save that flat file according to the name. Okay, but when you're dealing with the DBMS, Hey, I want to create one memory. Okay, sir, I will be happy to help you. Just use one SQL command. By using one simple SQL command, a memory will be created. I want to create 4 memories. So use SQL command. Okay, 4 database memory will be created. And you will name each and every database memory according to what? According to your requirement. So the name can be meaningful. I can say this is what? This is why like groceries. Okay, and I can say this is what? This is why this is something like employees. Okay, something like this memory is meant for students. Okay, and this memory is meant for something like departments. Okay, like this you can create each and every individual memory just by using a simple SQL query. Okay, and the second thing, first thing is creating database memory is completely fine. Second thing is creating tables. Okay, and again in each and every database memory you can create what? You can create a tables. So tables is a place where you can store the actual data. Okay, table is a place where you can store what? Where you can store the actual data. Okay, you can create tables. You can create tables. Okay, you can create tables. And the third point is creating tables is very easy. And what? Inserting data inside the table. Third one, inserting data. Inserting data. Fourth one, what? You can insert data. You can update data. Fifth one is what? You can also read data. Reading data is going to be very easy by using database management system. Reading data is nothing but selecting the data. Okay, and sequence is missing. And again you can do what? You can delete the data. Deleting. So by using DBMS software, creating database memory is going to be easy, and again it is going to be permanent. You have two options. If you want to keep it permanent, you can keep it permanent. If you want to keep it temporary, you can keep it temporary. But creating memory, creating tables, inserting tables, right? Updating data, reading data, and deleting data is going to be very easy. Okay, and also what they are saying, hey boss, DBMS is a software. If you want to talk to the database, you should have DBMS. You cannot directly talk to the database. You cannot directly talk to the database. What does it really mean? What they're saying is DBMS will act as an interface. A lot of people have a confusion when I say what is an interface. DBMS will act as an interface between user and the database. Okay, now focus here, guys. This is very important. This line is very important. When I'm saying DBMS act as an interface between user and the database. Now you see, so we know that okay, the web application are divided into 3 layers, right? The first layer is the front end layer. We have discussed things in the very first class, right? The front end layer we have, right? And then there will be a back end layer, okay? And there will also be what? There will be a database layer or persistence layer. You know, focus here. Persistence layer. Okay. You have front end layer, you have back end layer, and you have persistence layer. Okay. So the end user, there will be end user. The end user, the job of the end user is what? End user will open the application, online the application. The online application can be anything. Okay. He will interact with the application. So while interacting, he may submit a lot of data. So this is what front end application, FEA, right? And again, this is what back end application. So let us say that the front end person is entering his name. So he wants to register for some courses. He is entering his name, something like biology, right? And this will be transferred as a request. As soon as he clicks on, he clicks on submit button. Okay, this is going to be sent to the backend application. So the backend application can be Java, Python, anything, any programming language that you can use. Let us use Java, right? and this data, this is a data, this has to be stored in the database. Let us say that this is a database, Oracle database. Okay. Now we are discussing about DBMS. We are able to see FE front end, we are able to see, and we are able to see backend application, and we are also able to see the database application or database layer or persistence layer. Okay, which is what we are using Oracle. Where is this DBMS? Where is the concept of DBMS here? I can see only three things: front end, back end, and database layer. So this is one layer, this is one layer, and this is another layer. Where is the concept of DBMS? So DBMS is going to be in between backend layer and the persistence layer. So it is going to act as a mediator. DBM, yes. It is going to act as a mediator between what? Between the backend layer and the persistence layer. The mediator means what? You cannot, the backend people cannot communicate to the database directly. If you want to talk to the database, can I talk to the database directly to the from backend to DBM, the backend to the database? Can I do that? You cannot talk to the database directly. If you want to talk to the database, you need to what? You need to pass your instructions to the DBMS. There is a system. So this is the software. This is software. It is a mediator. Whatever you want to communicate it to me. It says DBMS says if you want to communicate to the database, don't communicate to the database directly. You just communicate it to me. Whatever the things that you want to do, you just let me know. Okay, I will make sure that your things are addressed. Your queries are addressed. Okay, now if the backend team says, if the request from the backend is like, hey, create a database. What? Create a database or create a table. Okay, this will be communicated by using the SQL language. By using the SQL language, this will be communicated to the database management system. Okay? This database management system is responsible to create a table by communicating with the database. How do you communicate with the DBMS? You will use an SQL language, SQL query. Okay, you will supply the instructions to DBMS by using SQL query. Okay, now this DBMS is responsible to do what? It is responsible to create a table by communicating with the database. You cannot directly, can I communicate directly to the database? If you ask me, no, you cannot communicate directly to the database. Why you cannot communicate? Because there is a DBMS, it is going to act as an interface. And what is DBMS? I can say, can I say that DBMS is a mediator? I can clearly say that the DBMS is what? DBMS is nothing but a kind of mediator. See guys, whenever you are seeing the word interface, understanding these interfaces can create a lot of confusion. Now let me help you with the real-time analogy. Okay, now focus on this analogy, then you will all your doubts will be clarified. Let us say that for example, what I can say, okay, let us say that hotel example or restaurant example. Okay, you are visiting a restaurant. Everyone has an habit to visit a restaurant very often, right? A restaurant, let me take that, this is a restaurant. Okay, the name of the restaurant is something like Selvam restaurant. Okay, restaurant, and you are visiting the restaurant. Now we focus here inside the restaurant. I can say that there will be a separate dedicated place for the kitchen, a kitchen, and you might be seen it very often. They say that it is a restricted area. So you cannot get into the kitchen. You might be seeing this as an as a signboard, restricted area in front of kitchen, right? And you have wash basins to wash your hands and so many things. And if you are visiting this restaurant as a customer, let's say that you are the customer, you are visiting to this restaurant, is you, okay? And you would like to have some food and you are visiting this restaurant. Okay, the moment you visit the restaurant, the waiter, okay, there will be a waiter. A waiter will come to you and the waiter will ask you, hey, what do you, hey sir, welcome to our restaurant. What you would like to have? What you would say usually? What you would say? You would communicate whatever you want to have to the waiter. Let us say that you are saying, I want chicken biryani. So this is you, and this is waiter. Okay, you would communicate whatever you want to the waiter. The user is like, user is a your customer. Your customer looks at the menu. What he would say, he would look at the menu and he will place something. He will place whatever he likes. Let us say he's placing, I want chicken biryani, and also he will say, I want chicken biryani. Along with that, please bring me some melons, some lemons, and more slices of onions. Okay, the interaction is happening to the waiter. What the waiter will do? Waiter will take the order, takes his order, and he will understand the customer's requirement, and he goes to the kitchen. Right, in the kitchen there will be a chief chef, and he will say, the waiter is waiting for the chicken biryani, please make it quick. And he will communicate the actual requirements. Okay, and inside the kitchen, what will happen? It will have, the chef will make take requirements of steps to take some steps to fulfill the customer's request. Like he will consider some ingredients, right? And he will process what he will start cooking. He will take some ingredients. Okay, according to the customer requirements, he will do what? He will start cooking. Okay, now let us conclude this. Okay, now here the U is nothing but what? The U is nothing but the end user. Or else you can say that, okay, the application, backend application or front end application, whatever it is. Here the waiter is nothing but, okay, if you want to convert this analogy to the real-time application, the waiter is nothing but what? DBMS, database management system interface. And your kitchen, the staff inside the kitchen. Okay, you have a kitchen. Inside the kitchen there will be lot of chefs, right? Lot of chefs who actually does the cooking. Here the kitchen is talking about what? The database. Okay, the customer cannot go inside the kitchen directly and ask the chef to do this, to do that, and add little salt, add more salt, make sure that masala is less. He cannot do that because it is restricted area. Whatever you want to do, you has to do what? The customer has to communicate with the waiter. Waiter will take care of the customer's requirement, and the waiter is responsible to fulfill the customer requirements. Okay, the waiter is acting as an interface. He's acting as a mediator between the customer and the kitchen. If you convert this to real-time analogy, same thing is happening. The customer is what? The customer is the user, and the DBMS is what? Waiter is what? The waiter is DBMS, and the kitchen is what? Kitchen is actual database. Making sense? So this DBMS layer, you call this as what? That's why you call this as was interface. Interface means a mediator between the user and the database. Okay, say something. Are you able to understand this or not? Everyone?
Yes, sir.
Okay, now you see, DBMS not only does the mediator job, what it will also do, it is going to interpret. It interprets the queries. Well, usually the backend team, they create a lot of SQL queries. It interprets the queries and translates them into actions that the database can perform. Okay, any request is coming from application. Okay, and if Balaji is a data that needs to be stored in the database, and you talk to DBMS in the form of SQL language, and the job of the DBMS is to do what? Translate the interpret the query, understand that query, and translate them into action. For example, if your requirement is, if the user requirement is, hey, please create a table, you will writing an SQL query to create a table. Okay, this request is supplied to DBMS. A DBM will understand the SQL query. After understanding the SQL query, it will ensure that it is coming into the reality. The actions are performed in the database. What are the actions? A table will be created. Whatever it is, give it to me, which is what DBMS, I will take care of that. That's it. That's why it is called as interface. Okay? You will come across this interface very often, right? And what is the next thing? See, now we have understood the importance of database, creating database memory, things like that we can do, like inserting data. Now again, they have differentiated DBMS into many models. Now focus here. Models of DBMS. Models of database management system. There are three types of database management system in the real world, guys. Only three types. There are three types of database management systems. Or else I can say that there are three models. Or else I can say that there are three. Let me do it like this. Models of DBMS. There are three types of DBMS models. DBMS. So I'm talking about the evolution of DBMS. So when you have a phone, okay, you have phone with camera and you have phone with the phone with a screen, phone with a digital screen, and you can do a lot of things in your mobile phone. But in the first mobile phone was not like that. It was a keypad phone. From keypad phone, the lot of changes happened, and the technology has become far more advanced. So now we are operating a phone which has a camera with eye pixels as well as with eye zoom capacity. Right? Likewise, there are three types of DBMS models. The first DBMS model is hierarchical database management system. Hierarchical database management. This is the first DBMS model. It is, you can also call it like HDBMS. Right? I can say that this is the first DBMS software. This is the very first DBMS software or tool. Please be informed that this is the very first DBMS software. This is the first DBMS software or tool. So whenever I say DBMS, just imagine this DBMS. Interface. DBMS is an interface which is going to communicate with the database. Okay, I'm not talking about the database. DBMS is an interface which is going to communicate to the database. Okay? HDBM. Okay, the first software tool. Example of these tools are, you have something like information management system. Information management system. It is one of the DBMS tool. It is what? It is one of the DBMS tool. You can say IMS. Okay. Second, there is another DBMS tool called. Let me take this. Okay, let us take it. Let us use this space. Now second one. Second one is, you have something like what we call it as the network database, NDBMS. You have network database management system. Management. Okay. You can call it as what? NDBMS. It is one of the model. Okay, so this is what? This is the second DBMS model or tool. Or sir, can you give me one example of this NDBMS? Okay, there is something like integrated database management system. Example. Okay, these are just the software tools. Database management system. These are just the software tools. Like, see, in your mobile phones you have something like Android, you have something like Mac, Apple, Mac operating system, right? And if you take BlackBerry mobile phones, it has some other operating system, right? uh, that is like this. It is just like that, right? So even in DBMS, these are the models. So if you talk about DBMS, it is an interface, okay, and this is one of the interface, and you can communicate to it in a different language, and its features may be completely different. And this NDBMS is again one of the DBMS interface, and these features can be different. But unfortunately, these two databases are not being used anymore. Okay, in the real time, if you go to any company, they are not following this model. There is no database which is using these two data DBMS system. Okay, please be informed that the above DBMS are outdated and it is not being used anymore. Okay, now what is the DBMS that we are using now? Now we are using what? Relational database management system. Relational database management. So this is the DBMS that we are using now, and this is very popular DBMS, and many databases are using this DBMS. Many databases are using this DBMS. Please be informed that this is the very popular DBMS. Popular DBMS nowadays, and many databases are using this RDBMS. Okay, and again under RDBMS, okay, so let me repeat this. There are three DBMS model. This model, there is a hierarchical model. Okay, this is the old one. Due to some drawbacks, due to some reasons, they have stopped using this, and they also add the other option called network database management system. And again, there are some drawbacks, and there are some what we call it as the performance issues. That's why they stopped using these two databases, and they start introduced what? The relational database management system. Why? Because to overcome the drawbacks that we have in this two. Okay, don't worry what are the drawbacks and all. Nowadays, full-fledgedly we are using RDBMS. Okay, now we will understand what is this RDBMS. Again, this RDBMS has two different models. Okay. You might have heard these things in the DBMS subject. Not sure. The first thing is Object Relational Database Management System. Database Management System. This is called as what? ORDBMS. Okay. And the best thing about Object Relational Database Management System is what? It has a very best thing. Okay. You can use this only with the tables. If you create a table, okay, that you are just what? You are creating a database. Okay, so the data can always be stored in the form of tables, the form of a table. Okay, because when you take a table, don't you think that table is completely structured? Whatever the table that you take, it is the collection of what? It is a collection of rows and columns. Okay, there are many rows and there are many columns. Don't you think that it is going to be very much organized and very much structured, and there will be no data redundancy if you follow some rules and regulations? And inside this table you can store any kind of data, if you ask me, because it is completely structured. Definitely you don't miss any data if you follow the rules and guidelines that is given by the database. right? Table is the best option, right? Table is a very best option to store data, right? That's why in the relational database management system, data can always be stored in the form of tables. Okay, and again, if you ask me what is a database, with in context, I mean, in the context of ORDBMS, if I ask you what is a database, you should say a database, a collection of tables. A database is a collection of tables. With respect to ORDBMS, if I ask you what is a database is a collection of tables. Having said this, if you take if you're taking Oracle database, guys, okay, inside the Oracle database, you have data, but the data will not be in any other form. It will be in the form of tables. You will have a lot of tables inside this Oracle database. Table 1, table 2, depending upon the requirements, you will be having lot of tables inside this Oracle database, right? Table 1, table 2, depending upon the requirements. If I ask you, I can say, right, this is a database. What is database? Database is nothing but the collection of tables. Collection of tables. Table 1 and table 2. And again, what is a table? What is a table? I can say that a table is what? A table is a collection of rows and columns. A table is a collection of rows and columns. Right? This is what is database. And what is a table? Right? You know this. What is a table? If you take any table, definitely you have rows. Okay? You have collection of rows, right? And also let us say that these are the rows. Okay, row 1, row 2, row 3, row 4, row 5. At the same time, you also have what? You also have the collection of columns. Columns. Okay, this is a table. Typical table. You have collection of rows and columns, right? And the horizontal things are rows, and the vertical things are what? Columns. Making sense? Rows. And this one is what? This one is columns. Okay. And again, if I ask you what is a row? Okay. Row is nothing but a group of columns. Group of columns. I am saying group of columns, isn't it? So if you take this row, it's a combination of column 1, column 2, column 3, column 4, column 5. There are 5 columns. Collection of columns is called as a row, or group of columns is called as a row. I can say that. And again, we try row. Okay, group of columns. So again, they are calling the row as what? You can call a row. A row can also be called as, okay, record. You can also call it as a record, and you can also call this what? Tuple. These are the other words. These are the other words that you have, which you can use in place of rows. Either it can be row. Okay, if you're not happy to call it as a row, go with a record or go with a tuple. Both are, these three things are one and the same thing. Okay, and again you have what? You have column. Okay, what is a column? A column is nothing but a column can also be called as a column or attribute or fields. Column can also be called as or you can call it as attribute or field. Okay, now I am showing you what? I am showing you a database. Inside the database, you can place a table. Inside the table, you have rows and columns. Okay, to communicate with database, we need what? We need DBMS. What is DBMS? Database Management System. It is a software. It is a software. So This software will understand only one language. You may be knowing English, you may be knowing Telugu, you may be knowing Tamil, so many languages you know, or you may be knowing Java, you may be knowing Python, whatever it is. Okay? But this DBMS can understand only one language, which is what? SQL language. So I can say that please be informed that SQL language is very much mandatory. Okay? Please be informed that the SQL language is mandatory as the databases are completely depends upon the structured query language, SQL language. That's why these databases are called as SQL databases. So when any database understands the SQL language, right? So they are called as what? SQL databases. Why SQL databases? If you want to create a table, you can communicate that. But how you can communicate that? By writing an SQL query. If you want to create a row, write an SQL query. If you want to create a column, write an SQL query. If you want to create, if you want to insert something, you want to create a database. Okay, write SQL query. If you want to update, write SQL query. If you want to do what? If you want to read, okay, write SQL query. And again, if you want to delete some record, write SQL query. Whatever it is, everything has to be written in the form of SQL query. That's why these databases are called as what? SQL database. So what are the examples of SQL databases in the real time? Ask me what are the examples? Okay. You have Oracle. Oracle is very popular. Very popular. You have SQL Server, you have. So MySQL. Okay. You have something like DB2. Okay. You have Sybase. You have PostGRE. There are so many things, but Oracle is very popular. Let me tell you something. If you understand the Oracle database, understanding SQL Server, MySQL, DB2, Sybase are very easy. Only minor changes are there. To operate tool. Yes, it is just like you are using an Android phone. Android phone, and you can operate Android phone very easily. Anyone can operate Android phone, right? And tomorrow you are switching to what? Apple phone. Okay. Do you think that it is going to be operation is going to be easy or difficult? Right? You can. The futures are little difficult, but again, you can operate Apple phone as well. Right? Even though both are following different platforms, or both are placed on different platforms, dealing with the phones are very easy. Likewise, if you understand Oracle, dealing with other SQL databases are going to be very easy. That's what I'm trying to say. Okay. This is coming under what? Object Relational Database Management System. There is another database system. There is another popular database system we have. What is that? We have what? We have something like object-oriented database management system. Second one. Let me increase the size. Okay. Second one is what? Object oriented database DBMS. Database management system. It is what? OODBMS. Okay. So in the object, look at this. In the object relational database management system, you use tables. Data is stored in the form of a table. But in the object oriented, the data is going to get stored in the form of objects. That is the only difference. Please be informed that the data in the OODBMS model will be stored the form of what? The form of objects. The form of objects. Okay, if I ask you, if I give you the table, like this, by looking at the table, you should say, okay, this is ORDBMS. This is what? over DBMS, because the data will be stored in the form of table. If any data is getting stored in the form of table, okay, that is called as what? Over DBMS. Okay, and if I give you this, this is an object. It's an object. If I tell you what kind of database model is this, you should say OODBMS. If you want to store any data in the ORDBMS, you have the what, you have something like serial number, you will be having serial number, and you will have having name, anything you can take. Okay, the data will be like this. Okay, 1 2, okay, some you keep some row numbers 3 and 4, and you will have some information like ABC. Let me take it like some information. Okay, information will be stored in the form of table. Okay, you want to do the same thing, you would do the same thing in the form of object. You take S and O, okay, name, and you take what, you take 1 ABC, will be like this. Okay. 1 ABC, 2 WER. Let me take only 2 rows. This will be like this. This will be in the form of object. Sometimes they say this will be in the form of JSON. Will be like this. Okay, the first Angular braces or what? You don't have to understand about this really. I'm just giving you the difference. So when ORDBMS is representing a table, OVDBMS is representing an object. Object will be like this. And if you want to get the name of the third serial number, first it will get into the serial number, and it will get inside the object, and it will find the number 3 here, right? And it can able to fetch all the data. Everything will be in the object, right? I can say that this database are completely depend upon the OOPS principle. This OODBMS database, OODBMS databases are completely dependent on OOPS principle. You know what is OOPS? What are OOPS? Object oriented programming system. What are these principles? You have polymorphism, you have encapsulation, you have abstraction, and you have inheritance. Okay, and since this database is depending upon OOPS principles, these databases are called as NoSQL programming language. NoSQL or NoSQL databases. NoSQL databases. The interview room, they would ask you, are you familiar with NoSQL databases? What you would say, since we are learning Oracle? No, sir, I am not familiar with NoSQL database. I am familiar with SQL databases. So what is the database that you know in SQL? You can, after learning Oracle, you can also keep MySQL. Okay, you can also keep SQL Server if you want. You can keep the remaining two other database, because they are going to be very similar. Okay, and if they are asking you, like, are you familiar with OODBMS? We are not familiar, but what are the databases that is falling under OODBMS? The very popular database is what? You have something like MongoDB, which is a NoSQL database. You have something like Cassandra, which is again what? Which is again a NoSQL database. There are so many, but these two are very popular. These two are what? These two are very, very popular database. Right? What we have understood today so far? We have understood the drawbacks of the flat files. To address the drawback of flat files, we are going for database management system, right? And this database management system can do a lot of operations: create database memory, create tables, inserting data, update data, reading data, and then deleting data. Database management system, right? And it is an interface. This is going to act as an interface between the end user and the database. You cannot talk to the database directly. You want to talk to the database, first whatever you want to talk, whatever you want to do, take help of DBMS. You can interact only with the DBMS. That's why the DBMS is called as what? It is acting as an interface between the user and the database. So this is one typical example that I have shown you, the real-time analogy. After that, okay, see, uh, again we have started understanding about the models of DBMS. Okay, there are three models of DBMS. One, you have what? Hierarchical database management system. So this is not this is oldest model. We are not using that anymore. And we have network database management system. That is also the oldest one. Both databases are outdated, and no database is using these two models. Okay, and we have the very popular one, relational database management system, RDBMS. What is RDBMS? We are going to use only what? The data can be stored in the form of tables. If any data gets stored in the form of table, they are called as what? Object relational database management system. Again, a table, if you want to represent table completely, okay, you know, a database is a collection of table. And again, what is table? A table is a collection of rows and columns. Again, what is row? Group of columns, right? And a row can also be called as row, record, or tuple. We will come across these words very often. And the column is also called as attribute or field. Okay? And in order to deal with O or DBMS, what you have to do? Okay, you should know what? You should know SQL language. That I'm going to teach you SQL language as well. So SQL language is mandatory. We're going to talk to the database by using what? SQL language. That we will see. That we will see in the ongoing classes. And again, what is another type of model under ORDBMS? What? OODBMS. What is OODBMS? Instead of using tables, they use objects. Okay, they use object. Okay? And they depend upon OOPS. That's why they call us NoSQL. Okay, when you are preparing a resume under the databases, you will get a calls. Hey, are you familiar with SQL? Okay? If you are familiar, you can say yes, I'm familiar. Some companies they would ask, hey, are you familiar with NoSQL? Okay, so if you learn SQL, that is completely fine. But in future, if you have a time, once you understand Oracle, understanding this NoSQL is also very easy. Understanding Oracle, understanding this NoSQL is also going to be very easy. If you keep the Oracle as well as Mongo, Oracle DB is fine. Oracle DB is 100% fine. You still want to upgrade yourself. You still want to make some enhancements in your career. You can also learn MongoDB also. But try to completely understand what is Oracle. Then learning this MongoDB, remaining Cassandra, remaining DBs are going to be very easy. Because in any company, in any software company, they will not depend on only one database. They will be using an n number of databases. For the development, they use Oracle. For the testing, they use MySQL. Right? In the production, they may be using Cassandra. You will be dealing with you will not only dealing with one database. You will be dealing with many number of databases in the real-time application development. Cassandra. There will be set of 5 databases. If you look at the sets, there will be also MongoDB. There will be Sybase. Okay. For UAT, for the testing or in the lower environment, Oracle. Okay. In the testing environment, they use MySQL. Right. This Cassandra will be in the production environment, prod environment, and this MongoDB will be used in another lower environment. They don't depend on only one database. They will be dependent upon multiple databases. So that's why if you keep the combination of ORDBMS as well as if you keep the combination of what is the other thing that we are, where did it go? Keep the combination of ORDBMS and OODBMS, one in OODBMS. The resume will be completely becomes very powerful and you will get a lot of calls. Now, I'm not saying it is mandatory to learn NoSQL databases. Just learn Oracle. You will understand. You can self-learn this. That's what I'm trying to say. You can learn it by yourself. Once you understand Oracle, you can learn the MongoDB by yourself. You have to. Okay, this is all about today's class. Okay, tomorrow what we are going to do? Tomorrow we are going to understand the what is Oracle. We will understand, and we will understand the Oracle versions, and we will understand what Oracle installation, Oracle and versions of Oracle. Okay, and we will understand Oracle installations, and we will also understand how to create the user ID and password after the installation. Okay, so that's all for the today's class. I will send you these notes. Most probably the theory part will be completed tomorrow. Then we will start the installation. That's all from